All right, let's go through the in-class worksheet for limits and continuity part B. We have to look at left and right-hand limits of these. So, a little hard to see there, but this one says, take the limit as x approaches 2 from the left-hand side of square root of x squared minus 4. Well, if x is slightly less than 2, that means x squared is going to be slightly less than 4, and a number slightly less than 4 minus 4 is going to approach 0 from the negative towards the negative side. So the square root of a negative number, no matter how small it is, does not exist. If I approach 2, for number 2 here, from the positive side, limit as of x squared minus 4, square root of that. Well, if x is a very number that's just slightly greater than 2, well, it's going to approach 0 from the positive side. And positive 0, square root of that is 0. But since these two do not agree with each other, then the overall limit as x approaches 2 does not exist. All right, let's take a look at number 4. As x approaches 0 from the negative side, well, that would mean that x is a very small negative number, and then I'm taking the absolute value of a very small negative number, but the numerator stays a very small negative number, but the denominator, since its absolute value, becomes a very small positive number. So a very small negative over a very small positive, if they're the same number, would be equal to -1. Now, if I'm approaching 0 from the positive side, it means I have a positive 0, okay, so a very small positive number over a very small positive, the same very small positive number. Well, that's going to equal 1. All right, but since these two do not agree with each other, then the overall limit as x approaches 0 does not exist. Number 7, as x approaches -3 from the negative direction, that means -3 plus 3, it's going to be a very, very small negative number. So I have 36 over -0, which, well, that would approach negative infinity. If I look at number 8, we've got x squared as x approaches -3 from the positive direction, from the right-hand side, then it's going to be a number that's slightly greater than -3. So that's going to be a number that's slightly greater than 0, and I have 27 over 0. I'm sure that should be 36, not 27, sorry. That should be 36 over just a small positive number would be approach positive infinity. And since the two don't agree with each other, the overall limit as x approaches -3 does not exist. Well, let's look at number 10. As x approaches 1 from the negative direction, well, then 1 minus 1 is going to be a very small negative number over 2. Well, that's going to approach 0. Same thing with the positive direction. As I approach 1 from the right-hand side, 1 minus 1 is going to be a very, very small positive number over 2, which is going to approach 0. Since the two do agree with each other, the overall limit is 0 as well. Now, number 13, we have to do all three parts by ourselves here. So as x approaches 7, the limit of 7 over 7 squared minus 49, well, as x approaches 7 from the left-hand side, it's going to be a number just slightly less than 7 squared. It's going to be just slightly less than 49. So it's going to approach 0 from the negative side. So 7 divided by a very small negative number is going to be negative infinity. Approaching 7 from the positive or the right-hand side, x divided by x squared minus 49 is going to be 7 over a very small positive number, because just slightly greater than 7 is going to be just slightly greater than 49 when you square it. So that's going to be just slightly greater than 0. So that's going to approach positive infinity. And since these two do not agree with each other, the overall limit does not exist. All right, we'll skip number 14 since we didn't do piecewise functions. We'll talk about that next time. So a good hint on some of these is maybe try graphing them. If you graph them on your calculator, you'll start to see some patterns of these. So it's a good idea to understand how to graph these functions on your calculator and then look at the limits as you approach different values of x. And so, all right, that's where we're going to stop for today.